Hey guys, today we're going to be talking about solving inequalities. We're going through section 1.4, and we're going to talk about what is an inequality. We're going to be talking about what does it mean to be greater than, less than, stuff like that. We're going to be talking about properties of inequalities. We're going to be talking about solving inequalities. And then we're going to be talking about real world problems. Okay, so what is an inequality? Well, an inequality is just a mathematical phrase or sentence in which you're talking about one value being more than or less than another value. It's not an equation because there's nothing equal to anything. I mean, we can have equals in, but we'll talk about that later. And suppose that you were extremely rude and you asked me how much money I make per year. Okay. You asked me, you said, hey, Mr. Brooks, how much money do you make per year? And I would say, well, I make more than $10,000 a year. I make more than $10,000 a year. I make more than $10,000 a year. This does not say that I make $10,000. It means that there's some amount bigger than 10,000 that I make per year. Okay. So there's some amount. It could be like out here, it could be 20,000 per year. It could be 30,000 per year, but we know that it's got to be bigger. It's got to be somewhere on this number line that is greater than 10,000 per year. That's an inequality in a nutshell. In other words, we're not saying this specific value. Rather, we're saying there's a range of values that could be my answer. So in other words, in this case, I have X, which is how much I make per year, is greater than 10,000 per year. All right. In other words, X is bigger. My salary per year is bigger than 10,000 per year. Okay. Now, this symbol right here is the greater than symbol. Okay. We always read the sentence from left to right. Okay. And if you think about it, this symbol right here, the greater than or less than, this is the greater than symbol. If you think about it like this, imagine that this is like an alligator. Okay. The teeth of the alligator are always pointed towards the bigger value. Okay. So in this case, I have X is bigger than 10,000 per year. What if I made less than $10,000 a year? This is how it would look. It would say X is less than 10,000 per year. Why? Because now look, what's bigger here? The 10,000 now is bigger, which means the top, the biggest number that I could have, and I actually can't have a number bigger than 10,000 per year. So for in this example right here, if I'm making less than $10,000, that would be anywhere in this range right here, or even less. I might be losing money, right? I might be negative. So I'm less than $10,000 means that I'm on this side of $10,000. I'm greater than $10,000 means I'm on this side. And remember, the teeth always point towards the bigger one. Now, these two right here, these symbols without bars underneath, these are called strictly less than or strictly greater than. All right. Because what I'm saying here is I make strictly greater than 10,000. I don't actually make $10,000. If I wanted to say I might make $10,000, then all I have to do is put a little bar right here like this. So this sentence reads, I make greater than or equal to $10,000. So that means I could either be in this range out here or I could be right smack on $10,000. Either way, once again, it's still a range of values. I'm not saying I make $10,000 a year. I'm just saying I might make $10,000. I might make more than that. I know it's greater than or equal to $10,000 per year. Same thing with less than, right? Imagine here if we had, if I made less than $10,000 per year, right? Less than or equal to $10,000. That means I would be either making less than or I'd be making $10,000 smack on the money, right? I'd be less than or equal to. Okay, so that's the difference between the two, and these are very common, particularly when we're talking about a range of values. But I want you to think about it in terms of this is not a specific answer. I don't want you to think about a specific answer. Just think about it as a range of values, a range of answers. Okay, so what are the properties of an inequality? Well, just like with an equation, we have addition, we have subtraction, we have multiplication, right? And we also have division. Okay, you can add, subtract, multiply, and divide inequalities. All right, let's do some problems. So we're going to solve some inequalities here. So the first problem is x minus 2 is greater than or equal to 5. Okay. So once again, we're going to try to isolate the variable as with all either equations or inequalities. So I'm just going to add 2 to both sides. You end up with x is greater than or equal to 7. And boom, we can see that this is going to be correct. Now, what does this mean? Well, how can we check this? Well, it says greater than or equal to 7. So obviously x could either equal 7 or x could be greater than 7. Like, for example, x might be 8 or something like that. It'd be greater than 7. So let's use both of these cases just to check and make sure this thing is absolutely correct. So if x is equal to 7, then I have 7 minus 2 is greater than 5. Let's see if this checks out. 7 minus 2 is 5. 5 is greater than or equal to 5. So yes, this indeed checks out. Now, what if instead you have 8? So in that case, you would have 8 minus 2 is greater than or equal to 5. 8 minus 2 is 6. 6 is greater than or equal to 5. So once again, this statement is true and it checks out. All right, suppose we have the problem 6w plus 2 is less than 5w minus 4. Okay. Well, once again, we're going to try to get w by itself. So I'm going to bring all the w's over here. I'm going to bring all the numbers over here. So to do that, I'm going to subtract 5w from both sides. I'm going to take my time with this problem because I want to make sure that we have everything in order. 6 minus 5 is w, just w, or 1 w. And then w plus 2 is less than negative 4. Now what I've got is I'm just going to subtract 2 from both sides. And I end up with w is got to be less than negative 6. Okay. All right, so let's check and see if this thing actually works. So we know that w has to be less than negative 6. So that, for example, our test case could be w equals negative 7. Okay. So let's see if this checks out. So if w is negative 7, then we could say, okay, 6 times negative 7 plus 2 has to be less than 5 times negative 7 minus 4. And let's find out if this is correct. So we had 6 times negative 7, which is negative 42, plus 2. I'm just going to go ahead and finish this side. Negative 42 plus 2 is going to be negative 40, right? And then on the right side, we have 5 times negative 7, which is negative 35, minus 4, which is negative 39. So even though it's close, we can still see that this definitely checks out. Now I'm going to do 2 problems, and I want to show you something that's odd when dealing with division, because up to this point, we've only done problems with addition and subtraction. So what if we have 3w minus 2 is less than or equal to 4? Well, what we do in this case? Well, as always, we just add 2 to both sides, right? Just like a regular 2-step equation. 3w has to be less than or equal to 6. Now we divide by 3. And then you end up with w is less than or equal to 2. Now, Of course, there's two cases we really want to check. We want to check the case where W is equal to 2, and we want to check the case where W is less than 2, which I think a good problem for answer for that is let's make W equal 0, because obviously 0 is less than 2, right? All right, so for W equal to 2, and remember I'm plugging back into the original equation, you'd have 3 times 2 minus 2 is less than or equal to 4. Of course, 3 times 2 is 6 minus 2 less than or equal to 4. 6 minus 2 is 4, less than or equal to 4. So, of course, this right here checks out. Now, as for the other problem, we're going to have 3 times 0 minus 2 less than or equal to 4. Then we have 0 minus 2 less than or equal to 4. And then we have negative 2 is less than or equal to 4. We know negative 2 is less than 4, so that checks out as well. All right, we're going to take the same problem and alter it just a little bit to see what happens. Let's make this negative. Let's see what happens. All right, here we've got plus 2 on both sides, right? And then we're going to have negative 3 with W is greater than or equal to 6. Then we divide both sides by negative 3, and then you end up with W is less than or equal to negative 2. Right? So now let's check and see if this checks out. So let's suppose that, let's get rid of the case where W is equal to negative 2. Let's suppose that W is actually less than negative 2, and the easiest number I think of that's less than negative 2 is probably going to be negative 3. So let's try that. So if I have W is equal to negative 3, then I'm going to have negative 3 times negative 3 minus 2 greater than 4. When I do that, I end up with negative 3 times negative 3 is positive 9 minus 2 equal to 4, less than or equal to 4. 9 minus 2 is 7. 7 is less than or equal to 4. This is definitely not correct, right? Because we know that 7 is definitely bigger than 4. So what happened here? Well, I'll show you. When you divide by a negative, okay, you're changing the sign. Okay, now with regular division, you don't have to worry about this. Or when I say regular, just like who you're dividing by a positive number, you don't have to worry about this. But think about it. I am changing the direction, right? Negative, think about negative is like going in this direction. Okay, so for example, if I'm going in a positive direction, right, and then I multiply by a negative number, I am now changing my direction, right? Think about this as like times 3. This is times negative 3. I'm changing my direction when I'm going in a negative way. When it comes to doing equations, this doesn't matter because you have something that's equals. But when it comes to an inequality, on the other hand, this is extremely important because the inequality has to deal with a direction. Are I going forward? Am I going backward? Am I greater than? Am I less than? So when you're multiplying or dividing by a negative number, it changes. What you're supposed to do is as soon as I did this piece right here, I should have changed this symbol around. Okay? And so the symbol should now read like this. W is greater than or equal to negative 2. Why? Because the negative changes my direction. All right? So let's check this one out real quick. All right, now that we've got things in the right direction, let's see if it works. So if W is greater than or equal to negative 2, then W could potentially be 0, right? Because 0 is bigger than negative 2. So I'm going to plug back into my original equation to see if it works out. Negative 3 times 0 minus 2 less than or equal to 4. This, of course, now is 0 minus 2 less than or equal to 4. Negative 2 is indeed less than or equal to 4. It checks out. Okay, so be very aware, be careful. Make sure that if you have multiplying by a negative, that you switch the sign. You see that? When you multiply by a negative, you switch the sign. All right, so now we've got 4x plus 32 all divided by 16 is less than or equal to 3 over 4 times x. Whew, I mean, that seems like a lot. You're probably freaking out right now, but there's nothing to worry about. Think about it like this. Whenever you have any fractions, right? Um, 3/4 or anything like that, the best way to get rid of the fractions in an equation is to multiply the entire sentence, the entire inequality, or the entire equation by whatever the least common denominator is between the fractions. So let's say you had, I don't know, 5/2 x plus 3/4 is less than, I don't know, 12. And I'm not going to do this problem, but I'm just using it as an example. What's the least common denominator between 2 and 4? Well, it's 4, right? Because 2 times 2 gives you 4. So what you would do in this case is you multiply this whole side by 4, multiply this whole side by 4, and you end up with, let's see, 2 divided by 4, or 4 divided by 2 is 2, times 5 is 10x. 4 divided by 4 cancels, and you're just left with 3. And then 4 times 12 is 48. That's the best way to deal with these kinds of problems. All right, so in this case, we've got the common denominator is going to be 16, right? Because 4 times 4 gives you 16. So I'm going to multiply both sides by 16 here, okay? The 16s cancel. This 16 will cancel with this 4, and you'll be left with 4. So on the left-hand side, you just got just regular 4x plus 32. And on the right-hand side, you have 16 divided by 4, which is 4, times 3, which is 12. So you have 12x over here. Then what I'm going to do is, let's see. I think the best thing for me is probably going to be subtract 12x from both sides, I guess, just because I want x on the left, which means I'm going to have to subtract 32 from both sides. So then 4 minus 12x is going to be negative 8x less than, and then these will cancel. You'll be left with negative 32. Now, easily enough, what I can do now is I can say, okay, well, just divide both sides by negative 8. Remember, whenever I divide by a negative number, what happens? That's right, the sign changes. And that only happens if you multiply or divide by a negative. So in this case, my answer should be x is greater than 32 divided by negative 32 divided by negative 8. It's going to give me a positive number, and it's going to be positive 4. So we've got that x is greater than 4. And then once again, strictly greater than, there is no bar here, which means x can't be equal to 4 itself. So what's an example for a number that's bigger than 4? What is an x that is greater than 4? Well, 5. So let's try that. So let's see. If I have 4 times 5 plus 32 over 16 greater than 3/4 times 5. Let's see where we go from there. All right, 4 times 5 is 20. And I have 20 plus 32 over 16. I wanted to see if that's less than 15 over 4. Okay. Well, on the left-hand side, it's going to be 52 over 16 and less than. So if I wanted to figure out what 15 over 4 is in terms of 16, remember 4 times 4 is 16, right? So I'm just going to multiply the top and the bottom by 4. That's going to give me 60 over 4, and of course 60 over 16. So obviously 60 is bigger than 52, so this checks out. Now, another way you could have done that is just figured out what the decimals were. Okay, you could have just done 15 over 4 and seen if that was bigger than 52 over 16. Either way, it works out. It checks out. All right, let's do one more problem before we get into our real world examples. We got 12x minus 6 over 2 greater than 14x minus 11. So first thing I'm going to do, since we got this divided by 2, I'm going to multiply everything by 2 just to get rid of it, just make my life easier. That's then now going to give me 12x minus 6 on the left-hand side is greater than 28x minus 22. Remember, using the distributive property, right? 2 times 14 is 28. 2 times 11 is negative 22. Now, what I'm going to do is I'm going to subtract 28 from both sides, 28x from both sides. Now, I don't have to keep doing this. I could just put the x's on the right-hand side, but I'm just not doing that. I'd rather just flip the sign at the end. Okay, but I do strongly encourage you all to try to do that as well, and then see what happens. You'll notice that if you had flipped the sign, it works out the same. So you got 12x divided minus 28x. That's going to give you negative 16x. And then over here on this side, you're going to have negative 22 plus 6. That's going to give you negative 16. What do you know about that? You're going to divide both sides by negative 16. Remember, dividing by negative is going to flip the sign, and you will have x is less than 1. Now, what's a good x is less than 1 problem to try? 0, right? Because 0 is definitely not less than 1. So if I have x is 0, plugging back into the original equation, I'd have 12 times 0 minus 6 over 2 is greater than 14 times 0 minus 11. And let's see if this works out. 12 times 0 is 0, so you'd have negative 6 over 2 is greater than 14 times 0 is 0, so you'd have negative 11. And you can see negative 6 divided by 2 is negative 3. This obviously checks out. Negative 3 is indeed bigger than negative 11. Don't be tripped up by negatives, right? Think about everything in terms of a number line, okay? Am I getting further away from 0 in a positive direction, or am I getting further away from 0 in a negative direction? Just refer back to the number line. All right, we're going to talk about a real world example. Let's say that you are going to Edgar's Bakery and you want to buy some cookies, and you know that the cookies are $1.99 per cookie. Now, let's say it costs you $5 in gas and you got a $20 bill in your pocket. Question is this: what is the first of all, can you create an inequality that explains the situation? And secondly, can we solve for the greatest amount of cookies that we can get? All right, so we know it's $1.99 per cookie. Per cookie means that what is our independent variable here? What is it that we're trying to figure out the most of? Is going to be cookies. Okay. All right. So this is our independent variable. We're going to call this C for cookie, right? C is for cookie. That's good enough for me. Okay. So we're going to say it's $1.99 for every cookie that we purchase. Now we know our initial cost is going to be $5 in gas. We're going to have to spend $5 in gas to get to Edgar's Bakery, but that's okay. So plus $5 in gas. And we want to see what's the most amount of cookies that we can get, but we only have $20. We only have $20. Check this out. We only have $20. So should it be, so we know $20 is going to be on the other side. Is it going to be less than $20 or more than $20? Well, we only have $20 to spend, which means our $20 has to be bigger than how much money we spend total. So here is our expression. I guess I suppose it could be less than or equal to, because you do have $20, but anyway. All right, now let's solve it. Let's see what's the greatest amount of cookies we can get based on these parameters. So to solve, we're going to subtract 5 from both sides. Okay, and we get $1.99 cookies less than $15, right? Because after we spend $5 in gas, we'll only have 15 left. We can divide by $1.99, and then C is going to be less than, and I'm going to round to the nearest tenth. So we know C is going to be less than 7.5. Okay, so the most amount of cookies that we can get would be 7.5 cookies. Or I guess the most whole cookies we could get would be 7 cookies. Now let's just check it. We got $1.99 times 7 plus 5 less than 20. Let's see if this works out. $1.99 times 7 plus 5 is $18.93. And this indeed is less than 20. So this checks out. All right, I hope you all found this video very helpful. As always, keep studying. Practice makes progress. I look forward to seeing you all in the next video. Have a great day.